Hi everyone, welcome to part 2 of Pre-Calculus Lesson 6-4, Inverse Trig Functions and Right Triangles. So we just have a few examples left, and the first one is example 5. It says, a lighthouse is located on an island that is 2 miles off of a straight shoreline. Express the angle formed by the beam of light and the shoreline in terms of the distance d in the figure, and that's the distance across the shoreline. So we're going to start out with a picture. So here is the picture I have. Okay, so L represents my lighthouse. This distance over here is the straight shoreline. And here's the 2 miles from the shoreline that we know that the lighthouse island is. And we want theta, which is the angle formed by the beam of light, which is this thing right here, beam of light, and the shoreline. So we want to know theta. Okay, so it says express the angle formed by the beam of light and the shoreline in terms of the distance d. So what you're going to do is the same thing we did in example 4. Write an expression to solve for theta. So see if you can pick a trig function and write it out in the format that you would need. Now we obviously can't solve because d is a variable, but try and do that and then press play to check your answer. Okay, so you may recall that we have the opposite side and the adjacent side. So that is tangent. Tangent uses opposite and adjacent. So tangent theta is opposite over adjacent, or 2 over d. Now to solve for theta, because they said express the angle in terms of d. So that means solve for theta. We just did an inverse tangent on both sides. So theta is the inverse tangent of 2 over d. And that is my expression. That is my final answer. And I know it doesn't seem like a final answer because it just seems like an expression, but that's what they wanted. Okay, let's take a look at another type of example. In example 6, it says find all angles between 0 and 180 degrees satisfying the given equation. So in part A, they gave us sine theta is 0.4. So what we're going to do is we're going to do the inverse sine on both sides of this equation. And you're going to use your calculator to do that. Make sure you're in degree mode because it says between 0 degrees and 180 degrees. So type that into your calculator, write down your answer, and then press play to check your answer. Okay, so I did sine inverse of 0.4 is 23.6 degrees. Now, we need to think about this carefully because there may be a second answer because it says find all angles. That implies that sometimes there might be more than one. Now, you may recall that sine inverse is limited in its domain to the right half of the unit circle. Okay, so that's negative 90 degrees to positive 90 degrees. And that's because when we go to the left half of the unit circle, we will have repeat values. Sine inverse, if I was to use the left half of the unit circle, I would have a positive value in second quadrant, which is between 0 and 180 degrees. So I need to find out what that is. And all I'm going to do is subtract from 180 degrees. This is like a reference angle. And I'm just going to put this in and find the answer for the other angle. So our reference angle is 23.6 degrees, and I'm just going to find the second quadrant angle that works. And I can tell that because sine is positive, and remember, all students take calculus, sine is positive in first and second quadrant. Okay, so my answer was 156.4. So there are actually two answers to this, 23.6 degrees and 156.4 degrees. So what you're going to do is you're going to pause the video and try part B. Make sure to think carefully through whether there would be two answers or just one. Okay, for the first answer here, I just did cosine inverse of 0.4, which is 66.4 degrees. Now, I need to think through whether I need to do a second angle or not. Now, recall that cosine inverse has a range, or you're allowed to use values from 0 to 180 degrees. And those values will not repeat. So cosine is 1 to 1 on that interval, meaning that there will not be a second answer. There's only one possible answer for this. So that is my only answer. You can also tell that because cosine is only positive in first quadrant and fourth quadrant, and fourth quadrant is outside of this range. And this was positive, so it's not going to work for that quadrant. Okay? So let's take a look at another example. In example 7, we're starting to use a skill that is very, very important for this lesson and for future lessons. In this example, they said find the cosine of sine inverse of 3/5. And the strategy that we're going to use is to make a triangle and find the missing side length using the Pythagorean theorem. So what you're going to do, remember, this represents an angle. So start by drawing a right triangle, mark an angle as theta, and then use this fraction to label two of the sides of your triangle. Then use the Pythagorean theorem to find the third side. So pause the video and do that, and then press play to make sure you're right. Then we'll talk about the next thing you need to do. So in my triangle, I put theta at this top angle. And remember, sine is opposite over hypotenuse. So my opposite side was here and my hypotenuse side was there. Now I recognized this as a Pythagorean triple. It's a 3, 4, 5 triangle. If you didn't recognize it, you could use Pythagorean theorem. 5 squared equals 3 squared plus x squared, and then just solve for 4. So x is 4. Now, after you've made your triangle, all you need to do is do the cosine of this angle. So do cosine of theta now using your triangle. So pause the video, get an answer for that, and then press play to again check your answer. Okay, so cosine theta, cosine is adjacent over hypotenuse, so that's 4 over 5, and that's our final answer here. Now we're going to use the same strategy in the next example, but in the next example, they're giving us variables, so we need to be really careful. Same strategy, just using variables. Let's take a look. Okay, example 8 says write sine of cosine inverse x and tangent of cosine inverse x as algebraic expressions in x for -1 is less than or equal to x, which is less than or equal to 1. Now, a lot of people get tripped up by this last inequality and they kind of freak out because they're like, well, what does that mean? Why is that important? The reason that that part is important is that you know that it's not going outside of the domain of cosine inverse, and so that it'll stay in the domain where it needs to be. That's the only reason it's there. So we can pretty much ignore that and focus on what we need to do. Notice these are both cosine inverse x in both of these. So we're going to start off by creating a triangle using the cosine ratio. Now remember, this x is a fraction. It's x over 1. So try to make a triangle. Try to make a triangle. Label one angle as theta and use x and 1 as two sides, and then use the Pythagorean theorem to solve for the last side. Now you're going to get an expression, but don't worry. It's okay. Get the expression. Okay, so pause the video, do that, and then press play. So in my triangle, I put theta in this top corner. Cosine is adjacent over hypotenuse. So I knew that the x belonged here and the 1 in that fraction, x over 1, belongs on the hypotenuse. Now I solved using the Pythagorean theorem. I had 1 squared equals x squared plus, and I put a question mark there. You can put a y there if you want. I put the question mark just to keep the variables down, but y works as well, or any other letter you prefer. Okay, so I solved for that question mark, and I got this side is the square root of 1 minus x squared. So now the last thing you need to do is find the sine of theta using our triangle, sine of theta, and tangent of theta using the triangle again. So keep it in expressions, and we'll talk about simplifying it once you press play to check your answer, okay? Okay, so sine theta is opposite over hypotenuse, and this opposite side was this square root, so it's this over 1. So I just wrote it as the square root of 1 minus x squared. And tangent is opposite over adjacent. So it's the square root of 1 minus x squared over x. And this doesn't need to be simplified. I mean, technically we could do rationalizing and bring the square root to the bottom, but it's not going to make it any simpler. I cannot actually do this square root. Yes, this is a difference of two squares, but it doesn't actually have a square root. So I have to just leave it like this. These are as simple as they get for this answer. Okay, so that's it for this video. Please let me know if you have any questions or if you need anything in regards to this lesson.